So kind of the last consideration that I want to discuss is sharing Iceberg tables externally. Right? And this as a consideration is fundamentally one thing that gets the ecosystem at large so excited about Iceberg, right? It's gained very widespread adoption, right? Upsolver and dozens of other vendors are talking about and adapting Iceberg technologies and practices into their solutions. Because this kind of promise of a shared storage ecosystem offers a ton of flexibility and efficiency and cost controls and avoiding vendor lock-in. There's so many benefits that can come out of this, right? If we can have a single Iceberg table that could feed dozens of use cases, right? And you're storing and maintaining and optimizing that table once, and it's in an open format that is not tied to a specific proprietary vendor, there's so much efficiency that comes off of that, right? The architecture diagram that I have here in the slide, that's specific to Upsolver, but regardless of who's kind of creating and managing your Iceberg tables, if you look at the top of that image, in theory, you could have Snowflake querying Iceberg tables. You could have Databricks querying Iceberg tables. You could have Spark jobs running against Iceberg, Starburst, Trino, Dremio, Presto, Athena, Redshift. And many of these vendors that I just referenced have specific use cases that they're really strong at, right? Snowflake has become super impactful in the analytics space, right? But what if instead of having to write data into Snowflake in a proprietary format, I could just create an Iceberg table that Snowflake connects to and does all of its analytical stuff against, right? There's so much benefit that comes out of that. The challenge, though, and this is, and hopefully will be more of a short-term challenge, but we'll see, is that industry support of Iceberg is inconsistent, right? And I'm not going to present really a solution here to this problem, but I do want to make sure that take the opportunity to expose the problem so that we're all aware of it. Every vendor in the data lake, lakehouse, analytics space, whatever you want to call it, likely has some answer to supporting Iceberg, whether that's querying from it, attaching to it, writing into it. But the support is varied. And I'm not going to name any platforms by name because honestly, this is such a rapidly evolving ecosystem. There's a high likelihood that by the chance somebody's watching this recording, this limitation will have been addressed, right? But we have seen platforms out there that have varying support for different delete methods that Iceberg supports, right? Iceberg supports a couple different ways to delete data, either positional or equality. Feel free to read up on the differences between the two, but we have seen Iceberg vendors or vendors that support Iceberg have very minimal support for equality deletes. So if you're writing data into Iceberg and using equality deletes to delete rows, those engines may not be able to efficiently query from your Iceberg tables. We have also seen vendors out there that don't well support evolving Iceberg schemas. Now, one of the fundamental advantages of Iceberg is that the schema of Iceberg tables can evolve over time. It's one of the real attractive capabilities of the snapshot-based architecture is we can change an Iceberg table schema and simply write into that new schema. But I've seen vendors out there that once the schema evolves, they can no longer connect to the Iceberg table. I've seen vendors that support Iceberg, but only within a finite number of catalogs. I've seen vendors where a catalog in Iceberg, an Iceberg catalog typically points to the most current metadata. I've seen vendors out there that don't automatically update the catalog pointer to point to the most recent metadata file. That's a manual process, right? So I just wanted to kind of throw out some of the performance and functionality challenges that we've seen out in the industry. Some of these limitations make performance unreliable, and you'll see wildly different performance when querying Iceberg tables based on the technology you're using to run the query. It's not as much an Iceberg challenge as it is the way that that vendor supports Iceberg. So it's absolutely something you have to consider and test. right? This is a broad topic, but something that I do at least want to introduce as a challenge that we're seeing some Iceberg customers support. Some of the lessons we and our customers have learned: make sure you test Iceberg within the ecosystem that you plan on using it within, right? Don't just test an Iceberg table, create it, ingest into it, and query from it using one query engine and assume that all of the other query engines are going to return data in the same way. Right? I also have kind of a lesson here. The Iceberg ecosystem is really amazing in how fast it is iterating, right? Both Iceberg itself and the vendor ecosystem surrounding it. So I absolutely recommend anyone and everyone join and contribute and question the broad vendor ecosystem to improve their Iceberg offerings. Many of them have public Slack channels. Many of them have public repositories. We at Upsolver have joined many of the query engines communities to contribute to their open source projects so that we can improve Iceberg as a whole, right? And this community is iterating fast, right? And that's why I didn't want to name names in these few slides, because there's a good chance that by next week, some of those limitations will be gone and overcome. So make sure you test, make sure you push your vendors for support, and make sure you retest once your vendors have hopefully been accountable to address those issues. All right, so thanks for sticking with me during the meat of the content. The last thing I wanted to leave you with on today's session is kind of, where does Upsolver fit into this Iceberg ecosystem, right? So Upsolver, the company I work for, has a solution that we like to think is the most complete shared storage platform focused on Iceberg lakehouses. Right, now, this slide talks about everything that Upsolver does for Iceberg: zero ETL ingestion, declarative transformation, sharing of data externally. For the purpose of today's webinar, though, what I want to touch on is Iceberg optimization, bullet 1 there, right? And this is a new offering from Upsolver that allows customers to take an existing Iceberg table, one that you are maybe building yourself or writing data into yourself or externally to the Upsolver ecosystem, and allow Upsolver to apply performance best practices to making that table as efficient as possible. Right? Many of the actual manual administration tasks and maintenance tasks that we outlined in this session are things that Upsolver can apply to your Iceberg tables automatically to make sure they're cost effective and make sure they're highly performant. Right? Management and optimization in Upsolver, there's 2 different components to this story. The first is actually what we call our Iceberg Analyzer. This is completely free. It's open source. You don't have to register. You don't have to sign up. All you have to do is download it. And it's an open source utility that you can run on your workstation or anywhere where you have access to a terminal. And it will analyze an Iceberg table and show you what potential benefits can be achieved by optimizing the table. Right? So really, that's kind of a step 1. If you're not sure if your Iceberg table can be improved, well, let's look at it. Let's analyze it, see if there's any benefits. I'll show you a quick example of that here in this demo. Because this is open source, we very much want the community to help us with this. So we, of course, would love anyone and everyone to run the analyzer themselves. But if anybody has ideas and wants to provide feedback, maybe even contribute to it, we absolutely would love that level of adoption. So the analyzer, again, free, open source, no strings attached. We just love as much feedback and anyone to get value out of it as possible. And then the second component is, if you do find an Iceberg table that would benefit from optimization, Upsolver can continuously run that optimization for you, right? And the Upsolver optimization is made up of several different phases. And I just noticed the typo on the slide, so I apologize for that. Kudos to anyone who finds it for me. But Upsolver will allow you to apply continuous compaction onto your Iceberg tables. So if you're streaming data into an Iceberg table and you want to address this small file problem, Upsolver can do that for you. And one of the nice things about Upsolver's compaction is we take a kind of a very intelligent and algorithmic approach to compaction, where we compact when we feel like we need to compact, not just because you told us to once an hour, where you might be wasting compute by compacting files that don't need to be compacted. Upsolver kind of has this balance of compute cost versus performance gain, and we compact based on that algorithmic approach. But fundamentally, once a table is being compacted by Upsolver, you'll get smaller files optimized into larger files, You'll get more efficient sorting within each files. We do also merge updates and deletes into these compacted files. So merge on read queries become much more efficient. We're also applying our own compression to these files. So you'll generally also see some storage savings. And we can also help with the snapshot and data retention requirements that you might have, including even retention within a snapshot. So if you have a snap and you want to keep 7 days worth of snapshots, but within each snapshot, you only want to keep 24 hours, Upsolver's optimization can do all of those things for you. Right? The benefit, of course, once you attach Upsolver to an existing Iceberg table, is ideally you'll have a much more cost-effective and much more optimized